Hi, everyone. How are you doing? Hi,
Good,
Josh.
Pastor. I'm good.
Good. Glad to know that you're doing fine.
How are you doing?
Good. I just get out of another class, so just talking to my students. How's your class coming along? Okay.
Yeah, it's going good. I'm
Okay.
just doing some pre-calculus homework.
Who do you have for calculus?
Nickel. I
Nikolai?
Yeah.
Nikolai Basina?
Yes.
Okay. Yeah, we're in the same department, so good. I just saw him this afternoon. How do you like pre-cal?
It's good. He's actually teaches really good. I took it last semester. Yeah, last semester. I took it for the spring, I believe.
Mhm.
But online, it's just completely different. It was hard, so I had to drop out.
Yeah, some math classes might be helpful being on campus. So it all depends on the faculty sometimes too, you know. Well, good. I remember the calculus days. Yeah, I had to take I took pre-cal in high school, and then when I tested into UCR, I was 2 points away from not having to take calculus. So I ended up having to take 1C at UCR, and then I took linear algebra and multivariable and a bunch of class because I was a science major to start. I was a life science major to start, and then I switched my major. I went undeclared for one semester. Yeah, one quarter, and then they made me declare, so I declared. Yeah, long ago, years and years and years ago. So, well, good. You're on your way. So you gotta take the calculus series for STEM major. So,
Yeah, I do.
okay. Okay, so we'll start with our lab for today. Everybody check out Canvas. And then let me go open up Reppl real quick, and I'll share screen. So like I said before, you can always use your Visual Studio if you're comfortable with that. If you want to use online compiler, keep in mind that sometime later on in our lab, you might get a little bit different output, especially when we come across issues. And for example, when we're doing recursion or something, and when it's not able to give you the output, it's just going to give you the memory address. So it's going to look slightly different from one system to the next. Okay. So let's see. Let me get to CIS-7. So you can either download the lab or you can view it inside there, but the code is going to be a little small when you look inside the page. Okay, so today we are going to do bitwise logical operators and Boolean values. I always try to do the lab that will be relevant to what we talked about in the lecture, so you can see how that would translate to programming language, or how we would write a program that would represent some of the concept. Now, the first one is going to be on bitwise operator. And so we spent quite a bit of time working on binary in the last week. So I want to come back to that. And also we did two's complement, so we can further explore on how that's used in C++. So before the first exercise, it starts with talking about bitwise operators. So let's say that you're given the value 60 in decimal for A, and B is 13 decimal, And so we can then convert it to binary. So it's the 60 would be this, okay? And then the binary for the 13 would be here, be this one. Now we would then use the logical operator like A and B. So if we take this value and we AND it with this, and of course we can do it manually, but what we want to do is we want to use the computer to compute it for us. And then we can also use the expression A or B, and we would have an output. And then on the below table, it actually talk about all the symbols. So when you use the hat like this, then that will be your exclusive OR. So if you wanted to do exclusive OR in C++ or C, you would use that symbol. And then you would use the till, which is the wiggly sign, that would represent the binary, the binary ones complement. Remember, in the ones complement, we will simply flip the bits or not it. So that's another way that we can represent the ones complement. And in the later part of the program, we're going to make it shift. So the shift operator, this is gonna, when you point the arrow to the left, the double arrow is gonna represent that it's gonna shift left. So all that means is the operands is gonna move left by the number of bits that's specified. So if I put A shift left 2, right? Because if you look at A, the A values start with this right here, right? And if we are going to shift left 2, it's going to move, right? It's going to move the 2 ones right here 2 places to its left. So you're going to, and then it's going to push the 0 into the back. Okay, so basically you're going to move 2 spaces to the left. So these 2 are going to drop off, and then these 2 are going to be the front of it. So that's how you're going to have 1 1 1 1 0 0 0, which becomes 240 in decimal. Okay, so whatever the value that you indicate here for the left operands, that's going to be the shift value. So if I wanted to shift 5 places, then I would say double arrow, right? And then the 5 is going to be following that. So that's going to, what happened is going to move everything left 5 spaces, 5 bits, right? So it's going to move 5 bits to the left of it. So it's going to drop off the front, and then it's going to add the 0 in the back. So in the case that if we move 5, right, it's going to be 1, 2, 3, 4, 5. So this one is going to be in the front, and then the subsequent will be the 0. Okay. So that's what we're going to be doing with the binary left operator. And we can also shift right. So if we do the double arrow right and we give it a value, in this case, we would shift right 2 places. So the A, if you look at the A originally, right, is this right here. And if we shift right, then what happens is we are going to move it 2 right places. So it's gonna give us 0 0. So it's gonna add the 0 0 in the front because we have to move it right 2 places, and then it's gonna push everybody back. So the back 2 0 is gonna drop off. So that's gonna go away, and then the 2 0 is gonna be added to the front. Okay. So that's how we're going to be able to shift it right. And when you shift right, the decimal value is also going to get converted. So that's going to become 15 because the placement of the bits are different now. Okay, so that's going to be 15. So the way that we can represent this we write it in C++ would be like this. And I screenshot this. So if it's tiny, you can always pull it up like this so you can see. Right, you can enlarge the picture, or you can zoom in on Microsoft Word to, let's say, 200. So that way it will be closer so you can see, but I'm going to pull it on screen now. So I'm using Reppl. And in the Reppl, when you, if you use your Google account, it would, it would link your account so you can sign in using Google API or any of the authentication API that it provides you. I also think GitHub is on there. And then when you make a new program, you simply click a new Reppl button. And then it's going to give you this option. So you can choose your poison, right? You would choose C++ for this class. And then you can give it a name. I normally just name it by the exercise. So for example, I would say lab 2, exercise 1, or something like that. And I would give it a name, Bitwise, etc. Okay. I also suggest that you organize it by making a folder and put your files in the folder. You can also add favorites and then be able to do it. And then also, if you use the team option, you can program in team, you can share and so on. So the web capability on it is it's very flexible. So here's my program. And when you start writing your program, it would start with creating a main CPP, just like how you would do it in your regular IDE. And you can also add files and folder to it. So if you have like a project with the existing working directory, so it creates a file for you, and then you can add the files. And when you're done, you can download it. If you wanted to store on your computer, you can also copy the link to share it to people. So there are several ways that you can maintain your file using Reppl. Okay. So here's my program. I'm going to go ahead and close the other panel here so you can see. When we run this program, it's going to appear the result on the right like this. So this is the example program. You would start C++ with including IO stream, right? We know that we use that for C in and C out. So that's the library that we need, or the header file that we need for our C in and C out. Excuse me. And then using namespace std, there are a lot of different namespace, but we're using standard namespace. And this program is pretty straightforward. It's inside the main function. So you're not writing any custom function there or defining any function there. And in the main, you would start with your type. And here we would use unsigned in, and all that is that would be equivalent to our positive value. So whenever you say unsigned, that means it's not negative. Okay, it's positive. So A is going to be our variable, and it's going to hold 60 as a decimal or integer. And in the comment, we can add the binary values so we can actually see the bits, but you don't have to do that. You can use your calculator to do it real quick. It's easy conversion. My second variable is variable B, and it's also type as unsigned int. It holds integer, positive integer, and the assigned value is 13. So I initialize that at 13. And I have a third variable called result, and this variable, we're going to initialize it at 0 because it's going to store the result for us at the end. So now we are going to use the logical operator on line 10. So we would say result is going to be storing A and B. So it's going to take the binary value of 60 and the binary value of 13, and it's going to put that into the result variable. And then we want to show it. So we want to display it using a cout statement. And then here's our strings, so we know what it would be like, so that way it show up on here. And then we want to pass the result down here. So we want to bring it down and display the result. So we would say the result for A and B is, and then bring down the variable for the result and line. So once it operates that, it's going to give me 12 because 6C and 13 is going to give me a 12. Then we do the same thing for OR. So we would say result is going to be A or B. And we wanted to print that out. Then next, we are going to do exclusive OR. So we want to say the result for A exclusive or B would be, and it should give me 49. Okay. And then we would then start with the ones complement of A. So that is simply a negation, right? We talked about in this chapter, we talk about how when we not something, it means it's negate. So when you flip the bits or you apply the not operator to it. Now in C++, you can use it as an exclamation point, but because we're doing bitwise, you are going to use the tilde. And that's located on your keyboard on the top left. So basically it's going to be 60. And you ask, why is it negative 61, right? Remember that in the 2's complement to really represent the number, we flip the bits and then we plus the 1, right? So if I start with the 60 positive decimal value, if I flip its bits, if I not it, right, it's going to be negative 61. And so if I add the 1, it's going to really become negative 60. So that 1 bit represent the sign bit for that particular value. So it's always going to be the negative, the opposite of that value with an extra 1 bit. So then you would have that plus 1 is going to offset that and give you negative 60 if it's 2's complement. So for line 19, we simply apply the not operator or the 1's complement for A, and that's a unary. So it doesn't require 2 input, it only requires 1 input. Then we output that. So we would see that it's negative 61 here. On line 22, we would have the result of the 1's complement of A or B, right? So we know that, I'm sorry, A and B. So we know that A and B is 12. So its 1's complement is going to be negative 13. So it's going to be that because it's going to be the opposite of that value with an extra 1 or the negative 1 because it needs that 1 for the sign. So here it displays negative 13. And I simply tell the computer what I want, right? And then it's going to convert it for me and it's going to calculate it using the logical operator and it's going to provide the result. And then we're also going to do the 1's complement of A or B. And we know that A or B is 61. So the 1's complement for that should be negative 62. So that checks out. And you can always double check with the calculator, but again, your compiler calculates that for you. So it gives you the proper result there. Then we are going to shift, right? Left 2. That's going to be from our A value is 60. And we talked about moving it 2 to the left. So the 0 in the front drops off and we're going to add the 0 to the back. That's going to make it 1 1 1 1 0 0 0 0. So that will be 240. So it tells me 240 there. And then we're going to shift right 2 places. So That's going to push everybody back 2 places. So we're going to add the 20 in the front, and then the last 2 digit gets dropped off. So that's going to give us 15. So what I want is you can input the first exercise into your IDE or your online compiler, okay, as it's shown. And I want you to use that example, and I want you to replace A and B with P and Q and change up the value from 40 to 17. And then we're going to do the same thing for P and Q. We're going to operate the and, the or, the exclusive or, the not complement for P, right? The not, the ones complement, I'm sorry, the ones complement for P, the ones complement for P and Q, the ones complement for P or Q. And instead of shift 2, I would do shift 3. So you can easily take that program and modify it. So I can do something like this. I can say P is gonna be, and it tells me here that it is 40. So change that up to 40. And then I have a Q is gonna be 17. So use exercise 1 as a guide, like an example, a template. Okay, and then you would change this up to P and Q. Okay, and then if you want to edit the comment, right? So here I wanted to change that up and so on. So you get the idea that we would not make it exactly like the example, but we would use the example and apply the appropriate number, the value, right? That's given to us here. And if you know C++, you don't have to make it exactly like that as long as you fulfill these criteria. Okay. And for those of you who missed it last week, for the calculator, if you want to use your calculator, there's also a bitwise option. So you can double check in case you wanted to add the comment to it. Okay, so click on bin, there's a bitwise, and then you can enter, or if you have decimal value, let's say I have 40, okay, and then that's my binary. And then if I wanted to AND it with 17, and then I would have, oops, okay, yeah, I think it's 0. Yeah, you would get 0. And don't be surprised if it's just 0 for a P and Q, right? And so it should come out to be 0 there. So in the program, it shows you how you can write that in C++ for your bitwise. So your computer will take the input that you give it or the value that you set for the variable, convert it to binary, apply the logical operator, and then store the result. And then output it for you for each of the scenario. But instead of shift 2, we are going to do shift 3 for the first program. And then at the end, we would have return 0 and make sure that we have the curly brace to end the main function. Do we? Yeah, so you don't need to add the comments. You can if you want. You don't have to add the comments. The comments are there just to show you that that's the equivalent binary value so you can visualize it, okay? Some students do comment, but if you leave the comment out, I won't take off points. that's fine without the comment or with the comment. You're welcome. Okay, so if you run it and it gives you an error, that's just simply because maybe you have a typo or syntax error. So just double check, right? So you can follow the exercise 1 template and then just modify your variable name and the values. Pretty straightforward. Any other questions? So when you have the program written, you can take a screen capture. You can do alt print screen on Windows, or if you're using an Apple system, there's a link for how to do screen capture if you don't know how. Also on Windows, you can also use Snipping, right? So if you wanted to snip, so I normally require, the code and the output. So you can snip it by just drawing the square and it's just going to copy it like that. So that's a way that you can snip it as well. Okay. And then paste it to, a document. So you only have to upload one file. You can submit individual screen captures, but, that just takes up a lot of your tasks. So if you want, you can paste it on all one document and then upload it once. So put it on like Microsoft Word and then save it as a lab answer and then submit it. Okay. Any other questions? So in this exercise, our objective is to show you, right? We want to learn how to be able to use the logical operator we talked about in C++. Now, the way that we handle this is that we are using only 1 ampersand for the and we're using 1 pipe for the or, right? But later on in the later program, you're going to see that we're going to use double ampersand and double pipe for and or, because in the C++ statement, we have to use the 2 symbols to represent that logical operator, especially if you use it with the if conditions or in a conditional statement. Okay, but as its own, if we want to operate value, this is also valid for bitwise. So once you write your program, if you're using Reppl, you just click it, right? And then run. People call it Replit, but you know what Reppl stands for? Read, execute, and play. That's what it stands for. And that's really a Python thing, right? But in this one, you can choose any language that's available in the list. So you can run Java, C, Python, JavaScript, and so on. So for one, we just need to do the program for bitwise using the value that's asked of us, P and Q. Okay. Then on the next one, we would then use Boolean variables, and we would use the keyword bool. So before we look at the program for number 2, it talks about Boolean variables. So variables that can have 2 possible value, either true or false. And I wanted to touch on this because in this week, we work with logical operator. We looked at truth table. So when I come back to Boolean variables and kind of revisit it, and you probably learned this in CIS-5, right? So Boolean variables can only hold 2 possible value. Either true is 1 and false is 0. When you declare the Boolean variable, you would use the keyword bool. So that would type it as a Boolean type, bool type. Okay. And you would initialize or assign the value, and there are only 2 type of value that you can use. That will be either true or false. Okay. So the example that we have here is we have bool B1 is going to be true, and then bool B2 that might, and we would want to have a direct initialization by telling it false. So when you make the equal true, that is a copy initialization, where if you put it into the parentheses here, that's called the direct initialization. Because when it creates a variable, what it does is it's going to take a chunk of memory, right? Like it's going to cut a piece of the memory to use it to store the value for that variable. So when we say B1, right, it's going to associate B1 to a memory address. And at that point, it's going to store B1 either true or false based on the initialization. So here, if you say equal true, so what it's going to say is that value is then copied to the memory address. So therefore, you would have true stored to that memory address. Then when you do the bool here with the B2, it's also going to cut another section of the memory or use a memory address for the second variable, which is B2. And in this case, when we're using the parentheses, we would have false. That's a direct initialization. It doesn't need to copy that value to that location. It would store it directly into that location. Even though like on the upper end, like when you run the program and you output, it's going to be closely the same, right? But in the back, you have to think about how you using the RAM is important. So I'm teaching advanced Python this semester, and we talk a little bit about how we would be able to think about how we create containers for data and how we write our functions to really make our program more efficient, better perform by using memory less, right? Or changing our algorithm to make it run faster and better. So you can see that there's some difference in how you can initialize values. Then here you would use the curly brace, and this is the third variable, B3. And this is supported with C++11 and forward. So the newer version of C++11. I believe they're at 15 now, right? Or 16. So for B3, so when we can have an assignment by simply doing the equal sign. And you basically learn that in the beginning of programming classes by using the equal sign. Okay, so we talked about the bool type. And so when we declare the variable B1 and it is bool type, then we can say whether it's true or false. So if I tell it that I assigned it not true, that means it's going to be false. Why is it not true? Because there's an exclamation point in the front. And for B2, if I say B2 is not false, then that means that B2 is going to be true. So Boolean values are not actually stored in Boolean variables as the true word true or false. It actually uses 0 and 1s. So when you assign not true, right, it's going to put in a 0 for at that memory location. Where if you say not false for B2, it's going to put a 1 in that memory location. Okay, so the first one it's going to copy. The second one, it's going to directly initialize it. Okay, so that,
Professor, I have a quick question. I'm sorry. Just going back to the B2, when you went over the direct initialization, is that a shorthand for just assigning it false?
yes.
Oh, okay.
So, well, this is not false, so it's true, right?
Well, I mean, going back earlier.
Yeah, anything that you put inside here, it's when you use the parenthesis next to it, it's gonna directly initialize. So it's gonna,
Okay.
instead of creating it somewhere and copying it over,
Right.
it actually put it right at that memory address.
Oh, okay. Okay.
Okay.
Got it.
So the way that you initialize your variable is important. A lot of the times we just use the equal sign because that's the standard, right?
Right.
Like you would declare int a is equal to this.
Right.
But there are different techniques in how you would initialize it and and initialization can be used for different purposes. So this kind of gives you a very brief explanation on how they are different. When you started learning a little bit more about architecture like CIS-7 or the other upper classes, you're going to see a little bit more, or when you take 17C, the way that you write your program, the way that you create your container is significant because that's going to really speak about how your program is going to perform and the resources that's allocated to that program. And you
Wow.
want to save memory storage and processing, or you want to reduce the processes that you execute. So implementing nested loops might not necessarily be the best, even though it makes your program work. And I address this in my CIS 30E, which is advanced Python. So when you look at the loop and how it runs, it actually tells you the time that it runs each of the loop, and it tested the loops for you. So it tells you like, what's the best time that you're going to get out of that program. So this is kind of just give you a little taste on how you would create your variable. Okay.
Thank you.
You're welcome. All right. So we know that it's only storing 0 and 1s. And then when we look at the program, so my screenshot is a little different than the actual program that I'm going to show you because I actually did the program. So I want you to use this as a template, and I'm going to pull up the program so I can explain it to you. So this is number 2. So in the program, we simply just use include IO stream, right? I didn't have a second statement like using namespace std. You can put that. It doesn't need it because when you're using std : like this, you don't have to put using namespace std. So if you put using namespace std here, right, then you don't need to do the std : cout for each of the statement. So if you want to cut the work, then you put the statement there, and then you don't have to type out, std : cout. So I have a main function, and inside the main, I'm going to have it output, right? Yep. I have it output false and then not false. So at that point, what it's going to do, it's going to evaluate to 0. And the second one is going to be evaluated to 1. Now in the screenshot, it would be true here, right? Then at that point, it's going to evaluate to 1. And then not true is going to be evaluated to 0. Okay. Then underneath that, I have a bool type for B. So my variable B is a bool variable, and I initialize that as true. So as you see, true, 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 or false, right? Basically, it's storing 1s and 0, 1 for true and 0 for false. So I would then have it output what B is and what it's not. Okay. Now in the second exercise, it's asking you to do evaluate to false and not false, and true and not true. So we can customize this. So we would have to change this back to false. So first we're going to evaluate it to 0 or false, and then not false, which is 1. And then the second part, we're going to evaluate B as true and not true. So we would say bool B is true, output it, and then we would say not true with an exclamation point. So when we run this, it's going to give us, right, false for 0, not false is 1, and true is 1, and 0 for not true. So false is the first one here, this one. Not false is this one. And then B is true because we directly initialize that for true. So B is 1. And then not true, not B is going to be 0. So it flipped the bits there. Okay. So what this shows you is that while you initialize it as true and false, right? It actually stores it as 0 and 1s, and it outputs it as 0 and 1s for you. And we're going to use Bullalpha to convert it next. Okay. So for the exercise 2, you just have to evaluate it to false, not false, true, and not true. Take a screen capture. For number 2. So it's the opposite of the screenshot, and it would be like what I have in my Reppl.
Do you want a second document for this one as well? Or?
You can paste it all directly into that one.
Okay.
And then submit it that way. That's fine with me. Or if you want a separate document just to do a bunch of screenshot, sometimes answer for the lab, then that's fine too. I'm not picky. Okay. So that's just a simple program inside the main, right? A few lines, pretty easy. Then on the next one, we are going to work on Bullalpha. So sorry, I have an extra A in there. I didn't even catch that last semester. Okay. All right. So Bullalpha. That will be number 3. So while you finish with number 2, I will go ahead and go back to my folder and pull up Bullalpha. So Bullalpha is a way that we can actually output the ones and the 0 as the text true and false, right? Because what if we don't want it as ones and 0? What if we want it as true and false? Then you would use Bullalpha. Okay. So in the earlier program, right, we see that it only output ones and 0 because the system evaluates it to the ones and a 0. 0 for false and 1 for true. But as human, we want that interpreted as text for us. So in example 3, it tells you that Bullalpha is used to simply just convert the ones and the 0 into true and false. Sorry, a second, I need to get the laptop plugged in. It's about to go night-night. So you can start with using the example 3 program. And in this program, just like the last one, you start with include IO stream, which allows you to have input and output C in and C out. And similar to the last program, if you put using namespace STD at the top, then you don't have to do STD : C out, right? So here, basically, we tell the system to print out true. So it's going to give us 1. And then we're going to print out false, which is going to give us 0. So if you wanted to convert the ones and the 0 to the text true and false, then you would use C out, right? STD or Bullalpha there. And then subsequently, it's going to print out the word true or false. Because even if the system evaluates it to ones and 0, if you apply Bullalpha, then it can print out the text for you as true or false. So here's my program. Okay. In number 2, it tells you that you want to print out true values. Okay. So let's say that we want true, right? Not false, true, and not false here. So what will happen is it's going to give us 1, 1, right? True, true. So the first part is we didn't have the Bullalpha. And then the following statement after the Bullalpha, exactly the same as the top, it converts the ones into true as text for us. Okay. So now you would know how to use the bool type along with using Bullalpha. Question? Any question? Okay, so that's all you need to do for number 2 is to make it all your statement true. We can say true, not false, true, not false, but the second part we would use the Bullalpha. Okay, so it's going to give us true, true. Now, keep in mind that this lab doesn't require, for you to evaluate the program and answer the questions, but in the future, we will need to do that. Okay, so once you complete the program, take the screen capture and paste it to the document or save it. Any question regarding exercise 2 and 3? We're going to do 4 next. So in 4, it starts with giving you a table that contains logical operators for C++. Like I mentioned before, when we did the bitwise, we only use 1 ampersand. But when we write our statement, right, for our program, we would use double ampersand for an operator. Okay. And if both operands are non-zero, then the condition becomes true. And we talked about the truth table last time on Tuesday. Then on the second row there, we would have the OR using 2 pipe. So the logical OR operator, if any of the 2 operands is non-zero, then the condition becomes true. So if it's ones, then it's true. Then the exclamation point is used for the logical NOT. It's used to reverse the logical state of its operand. So you simply flip the bits, or if the condition is true, then the outcome will be false. Okay. So the example that they give you there. So now, this is one of the programs that I previously used in my 17A class, and I wanted to take this program and show you the real world application for the logical operator. And simply this program is using the not or operator. And the not or operator happens right here in the if statement. So this is a program that checks for loan qualification, right? Based on the income of the individual, the years that they work, and to qualify them for a loan. And you see that quite a bit, for when you look at websites, apply for loans for car, home, whatnot. And so let's take a look at the real program. So in this program, it's also a very simple program in that we just have everything built into the main. We would start with our include IO stream for C in, C out. we would have using namespace std, then we would start the main function. And for line 7, we would do a const double min income. So this is the type of the variable that we're using. And here is the variable min income. And we wanted to say $35,000. And we're using constant because this is a fixed value. And it's double is because it's a large number. So we want to type it that way we can handle larger number. Then on the second variable there, which is it's going to hold integer. Variable name is min years. That's the minimum number of years for at their job. And it's constant because it's a fixed value. And this is an integer, 5. Then the third variable, we are going to use income, which is your annual income. So we're going to prompt the user, right? How much do they make a year? And whatever they input, it's going to go into this variable. The fourth variable is going to be years, and it is going to store integer. When we prompt the user, we ask them how long have they been working, right? They can put in the number and it's going to store it into years variable. So now if you want to elevate this program, you can write a function, right? You can write a function that's going to basically obtain their income, another function to obtain their employment year, return from those functions, and then bring it down, call those function in the main. But since I just wanted to make it simpler for everybody because I don't know the level of programming that you have, we will write function down the line. But so in this, we simply ask them, we prompt them a question. What is your annual income? And you can say enter your annual income. That's more appropriate. And then we would cin, and it's going to store it into the income variable. Then we prompt them a second question. How many years have you worked at your current job? And they're going to input the value, and it's going to store that into the years variable. Then we're going to take the input values and we are going to apply it to a condition to qualify them for the loan. If not, their income is greater than the minimum income, or years is greater than minimum years, then we deny them. Okay. Now, can you just use the or condition? You sure can, right? I wanted to show you how you can use the not or. So if they don't qualify, that means that they're under the minimum income, or they would have to meet the year. So if I make $40,000, right, can I qualify? Yes, you can, because the or statement in the or for the or logical operator, only one condition needs to be met to be true. Okay, so if I make $40,000 and if I've only been working at my job for 2 years, it's going to qualify me. Okay, but if I make $20,000 but I've been there for 10 years, it's still going to qualify me because it's an or. Only one of those things can be met, and it will execute the body of the if. But if you want both of those conditions to be, if you require both of those conditions, then you have to change that to the and operator. So you would change the double pipe to the double ampersand. Then in that case, I have to be at my work for 5 years and make above $35,000 to qualify myself for a loan. Okay. So here we would reject them if they don't meet the minimum income or the years that we require. Okay. And so if any of the condition is true, then we would say you must earn this minimum income or have been working at this many years, else we would qualify them. Okay. And then we return 0 and finish out our main function. So execute this and you can test it. So let's say I make $30,000 and I work there for 2 years. Okay. So I'm under the requirement for both. So I got denied. But if I test this with one of the requirement is true, let's say I make $50,000 and I've been there for 2 years, I qualify. So the or would check out because I met one of the criteria, right? We only require one or the other. Okay, so you got a little bit better understanding of what we need. So you're going to use the example and to qualify the loan based on the income in the years. Okay. But instead of the income in the years, we are going to qualify the student based on credits, whether they earn a degree or not. So you can use that example, but we're not going to do the loan example. We are going to do, we're going to see if the student earned their associate degree or not. So they have to complete 60 or above credits or 5 semester as a full-time student, right? So if they have earned 60 credit or if they have completed 5 semester of being a full-time student, they can get an associate degree. And we have to use the not or operator. Okay, nor. So you can start with, instead of the double here, you would say const int, right? Min credit 60, const int semester 5, right? And then you can say int earn credits, int completed semesters, see out how many credits have you earned, put that into credits, see out how many semester have you been taken as a full-time student, see in credits if, and so on. So replace the income with the credits and the min years with the semesters, the min semesters. And then you can have your program. Any question? So we wanted to see if a student can earn a degree or not. So I'll put in the C out accordingly. Okay, and then change your variable and the const value. Any question? We still have a lot of time. We only have one more to do, so I'll give you a little bit of time to get that going.
What do we put on the and what do we replace the double income with again?
Credits.
Oh, okay, thank you. I was just
Yeah.
making sure.
Yeah. So you do credits and semesters. Okay. And then for this would be minimum credits, minimum semesters. And then the second income, we would then ask them earn credits, right? I would name it earn credits and then completed semesters. And then you can have the C out and the C in and the if statement. And make sure that we are using not or operator. I know you can use the or and the and, right? That can be easily implemented. I just want to know that you know how to use not or. I haven't taught 17A for a while now, but I do miss it sometimes, teaching C++. I teach C++ in this class. Other questions? We will likely finish early today, and so no rush. If you need help or have questions, let me know. So on this one, when you're doing the credits, you don't have to use double, right? Because credits are likely under the range where it would not be needing to be in the thousands. So you can use int, 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 and int. But the two that's going to be fixed value, the 60 credit and the 5 semester, that has to be constant. And then there you go. So in a college like this one, right, you would have a program that would evaluate students' credit when they apply to graduate. Like, you know, how a student would petition to graduate. When they petition to graduate, their application would go in and then they would do an audit on the transcript. So it's going to actually also check like the number of, not just the number of credits, but it's also going to check the right classes. So it's going to look at the transcript. So it's going to evaluate the list of courses that they completed. And all of that can be applied with the if condition, right? If this is met, right? If they have completed, let's say, 3 semesters of calculus, then, you know, check. If they completed life sciences, then check, and so on. So it would then have all the nested criteria. And then at the end, after the audit, the system would say, okay, that grant the student the degree. Okay, so make sure that we use credits and semester and the not or operator for number 4. Okay. Any question on 4? Okay, so before I show you my program, I want to go over example 5. So in example 5, we are going to use the logical AND operator. And this example shows to also qualify for loan with the special interest, right? Like this you see a lot. For example, if you are a recent grad and you're looking for a car, they're going to give you like $10,000 discount on a vehicle or a special interest on a car or, some kind of loan, right? Because they know that you are going to have a good job and you're going to pay for it. So the example that you see here, similar to the last one, what we're going to do is we're going to have a main function. And inside the main function, we're going to declare the variable and we're going to prompt the user and we're going to include the condition on how they can meet to qualify for the loan. So inside the main, we have the first variable, which is employed, and this is going to hold character. So we wanted to ask the user, are they employed or not, right? Because if we're going to loan them money, we want to make sure that they're able to pay us back. And the second variable is also going to be char type, as I'm using a separator here as a comma. So that will be char recent grad as well. So I'm going to ask the user if they are recently graduating from college or they graduated from college or not. Okay. And then we are going to prompt them the question with cout. Answer the following questions with yes for SY and N as no. Okay, so we want to make sure we give them thorough instructions on how to input, because people can type yes, and if you don't have it properly set up to store, which it's not, it's only going to store Y and N, then it's not going to work. So we want them to put Y and N. Are you employed? We're going to take their input and store it into employed variable. And then we're going to prompt them, have you graduated from college in the past 2 years? And we're going to take their input and put it into the recent grad variable. Then we are going to have a condition to qualify them using an if-else statement. If the variable employee, right, whatever they put into employee is yes or Y, and recent grad is yes or Y, then we qualify them for special interest rate. Else, if they don't meet both of these conditions, then we are going to tell them why they didn't qualify. You must be employed and have graduated from college in the past 2 years. So if I graduated 5 years ago and I'm employed, I will not qualify, right? I have to meet both of these conditions. So when you're using the AND operator, both of the criteria needs to be met for the if body to execute. Now, if I want one or the other, you saw the other one when we're using or, right? It only needs to meet one criteria out of the two. As long as one of them is true, it's going to execute. So the and operator is important. I want to emphasize this because when I teach 17A, B, and C, right, I see that student, if they're new to programming, sometimes they mix them up when they don't know how to use the logical operator properly. So I want to take this opportunity and make sure that you understand it. Some of you already, surpassed a lot of the basics, I know, but just to review so everybody's on the same page. Okay. So both of the criteria needs to be met in order for it to execute the qualify, right? It's going to see this out. It's going to display this. Okay. So now you see the example program. We are going to use that example program, but we are going to qualify them for different things. We want to use the logical AND operator to check if the user meets the following criteria for car insurance discount. They have to be 21 years and older, and they have to have been driving for 5+ years. And that's a realistic criteria, right? You get a new insurance and then they ask you, how long have you been driving? 5 years. Okay. How old are you? Right? Because they assume there have been studies and they use that study to base their criteria on that. The more mature you are, right, the less risk that you will take with your decision-making process when you drive. And that's not always true realistically for everyone, but that's just a generalized assumption, and that's what they use in their program. So we would then generalize the criteria and implement that into our program. We would use a logical and. So in your if statement, you simply just ask if they're, based on their 21 years and older, and if they've been driving for more than 5 years, 5+ years. Okay, and I did one, so I'll show it to you here. So I have a variable to store over 21. It's called over 21. It's older than 21 years of driving, more than 5 years. And then I use the same format as the example program. Answer the following question with yes, Y for yes, and N for no. Now, if you don't want to use char, you can use string, right? And then you just got to make sure that it match it with a yes. And sometimes they type it upper lowercase, then you have to check input validation. So just use Y and N, it's easy. And make sure that, if you want upper and lowercase, then you can specify, you have to implement input validation too. Okay, so I'm using all uppercase. Are you older than 21 years of age? Right? So, or this question can say, are you 21 years of age and older? Okay. Yes or no? Have you been driving for more than 5 years? And then that will store into years of driving. And then I would simply check the condition. They need to be 21 years and older, or older than 21. And then years of driving is yes, if it's more than 5. If both of this is true, then it's going to qualify them for insurance discount. Else, right, I just tell them why they didn't qualify. Run the program to test. Okay. Yes. Have you been, no, let's say I put no, right? I didn't qualify because I've been driving for less than 5 years. Now, can you convert this program in that they can put in the years, the number of years that they're driving? Sure, you can. Just have to change this to int,
right? And then make sure that your criteria is set to be, equal, greater and equal to 21, and greater or equal to 21, and then greater or equal to 5. Okay, so that's another approach. Any questions? So a very simple program, only using if else statement and logical operator. Okay, everything built into the main. You can also write different functions like get age, right? Set age, get years driving, set years driving, call that into the main, and so on. And then if you want to elevate it more, you can apply classes, objects, data structure. So a simple program can be elevated in so many ways. But this one is very easy and simple. We're just using variable and if else statement. Any question? So this is the type of lab that I usually do. I would give you an example program or something close to what you would be, you need to program. And generally they're short. There's some cases that are long, but that's down the line. But usually you only have about, less than 10 exercises. So 5 to 7, something like that. It's designed for you to, if you complete it in class with me, you'll be done by the end of the session. You can submit it, so you don't have to do it later. Okay. Question. So once you have the car insurance discount program, run it, provide me with your code and output. It should say up code and output. I don't need the actual CPP. If you screenshot it for me, that's good enough. But your screenshot needs to show your code and your output. So you can put everything on a document, all your screenshots, and upload it to Canvas. Questions?
Professor Gwen, I have a question about the curly braces. Would you mind going over that one more time? What's the use of that?
Which one?
The curly braces when you were just going over the Boolean.
Oh.
Is there a need for that use at all? Or?
For initialization. This
Um.
one for true.
Yeah.
For uniform.
For the uniform.
Yeah, that's just it's gonna be same as this. It's just gonna be for a newer version of C++.
Okay. Okay.
Yeah. So if you use this with the earlier version, it will not work.
Okay.
Mhm. So, as you notice, when you use your IDE or your online compiler, you can check, right? It will tell you the C++ version and then this GCC. That is important because that's what language version that it's supporting and the compiler version that it has. Okay. So they build these compilers for specific version of the language. and some will scale to the later. You just have to run the updates on it, right? Some or others, if it doesn't work, then you just have to install the newer version if it doesn't have backward compatibility. Usually it does. This is a Linux machine actually in the back. So because I've been using Reppl for a while and sometimes I use it for other languages, you can also see it. And then, if you use other languages that has shell, so you have a shell tab instead of a console tab. Other questions? Okay, no questions, huh? All right, so today we did bitwise, where we looked at the operator at the bit level, binary 0 and 1s. We looked at and or not, which is one's complement, exclusive or, and we did the shift with different digits. So using the double arrow key. Then we also did the bool type, and we talked about bool and Bullalpha on how it would evaluate to 1s and 0, and how we can convert the output from 1 and 0 to true and false in text. Okay. And then we also go over the C++ logical operator using not or and the and operator in number 4 and number 5, in which we would write simple program that would include real world criteria. And so we would have the if else statement incorporated in our program. Okay. And that concludes my session for today. And let me stop recording. Do you have any questions for me?